Phase Detection Autofocus, PDAF. Welcome to this presentation on Phase Detection Autofocus, or PDAF. In this session, we'll explore how PDAF works, where it's used, and why it's such an important autofocus technology in today's cameras and smartphones. What is Phase Detection Autofocus? Phase detection autofocus is a high-speed focusing method that works by splitting incoming light into two images and comparing them to determine how the lens should move. By measuring the difference between the two images, or the phase difference, the camera can focus extremely quickly and accurately, making it perfect for capturing fast-moving subjects like sports or children. Core principle. The core idea behind PDAF is phase comparison. When the two split images are perfectly aligned, the subject is in focus. If they are out of alignment, the system can calculate both the distance and the direction the lens needs to move, giving it a huge speed advantage over older systems that rely on trial and error. How it works: splitting light. The process begins when light enters the camera lens and is split into two separate images. In traditional DSLR cameras, this is handled by a dedicated phase detection sensor located beneath the mirror. In mirrorless cameras and smartphones, special pixels on the image sensor itself perform the same function, making the system faster and more compact. How it works: comparing and calculating. Next, the camera compares the two images to see if they are in phase or out of phase. If they don't align, the camera's processor quickly calculates how far and in which direction the lens should move to achieve perfect focus. The lens then moves directly to that point, no hunting, no delay. Where it's used: PDAF is used across a wide range of devices. In smartphones, it's often implemented as dual-pixel or all-pixel autofocus, helping deliver fast, smooth focus for photos and videos. DSLR cameras rely on a separate PDAF module beneath the mirror, while mirrorless cameras integrate the technology directly into their main sensors. Advanced forms and variants. Over time, manufacturers have developed advanced versions of PDAF. Dual-pixel autofocus allows every pixel on the sensor to detect phase differences, greatly improving accuracy. All-pixel AF spreads detection across the entire frame for better subject tracking. Many cameras also combine PDAF with contrast detection for enhanced reliability, especially in tricky lighting. Advantages of PDAF. The biggest advantage of PDAF is speed. Unlike contrast-based autofocus, which moves the lens back and forth to find sharpness, PDAF instantly calculates where the lens should go. It's excellent for tracking motion and maintaining focus during video recording. Limitations and considerations. However, no technology is perfect. PDAF can struggle in extremely low light or with subjects that lack clear edges or contrast. That's why modern cameras often use hybrid systems that combine PDAF's speed with contrast detection's precision to handle all kinds of shooting conditions. Summary and takeaway. In summary, phase detection autofocus provides a fast and accurate focusing method by analyzing phase differences between two images. It's a key technology in smartphones, DSLRs, and mirrorless cameras, ensuring sharp, real-time focus for both photography and video. As sensor technology continues to evolve, PDAF will remain a cornerstone of modern autofocus systems.